let's do parametric equations, where we talk about two equations where we have equation of y, also equation of x. Okay, equation of y, which is in terms of theta, also y in terms of theta also. So parametric equations talks about where we can't apply the implicity. So where we are going to introduce parametric. So parametric works like this. So if we have a function of x, where we are going to differentiate the equation of x in terms of theta. We're going to say the x over the theta is equals to x of the theta. Okay. So also on the other side, we're going to do the same thing, dy over the theta equals to d over the theta of y into theta. Okay, so let's focus here, guys. So as you can see that we have equation of x, also equation of y. So we differentiate it differently. So if we want to find the y over the x, we're going to say the y over the theta over the x over the theta. Remember, this is the derivative of the x equations. Also, this one is the derivative of the y equation. So we're going to say dy over the theta still the same as the theta over the x. Where this goes away, we're going to let with the y over the x. Remember? So we'll be doing the same thing. Okay. So what about if you want to find the second derivative using parametric? So using parametric, we're going to say if, okay, let me try to find the clear paper. Okay, so let's check the second derivative. If we want to find the second derivative is going to be d square y over the x square is going to be d over the theta into dy over the theta all over the x over the theta. Remember, this is the same as when you say when after you derive the x function in terms of theta, this one. So here is this is theta actually. So this is going to be the same, this x, I'm sorry. So we are going to have a derivative of the top. Remember, this represent to derive. Sorry. So we are going to derive. So where you are going to, if we analyze this, we are going to have d over the theta all over dy over the x, also the x over the theta. I think you guys can remember where we were going to left with the theta, which is going to be dy over the x into the theta. Remember this, they are going to goes away. And remember here we are going to left with the x also outside, which is going to be 1 over the x. So this when you are going to have an d square y over the x square. So if you can check, we are going to see something here. Let's see something like this. If our equation, it says that we're supposed to find the second derivative, we are going to use this equation which says t square y d square, and then says going to be the over the theta over the y over the x, also all over the x over the theta. Okay, so let's check our problem and then we solve it. Okay, so let's check this equation. So let's take we have a function of x which says x equals to 2 cos 2 t. Also we have the function of y which says y equals to 2 sine t. Remember, we're going to derivate the function of x. We're going to say the x over the t. Remember, it is in terms of t, which is going to be negative 4 sine 2t. And then on the other side, we're going to have dy over dt equals to 2 cos t. So remember, if we said if we want to find dy over the x, we're going to say dy over the t over the x over the t. So these two, they're going to cancel, and then you're going to left with dy over the x. Okay, so let's check that. So we're going to say, remember, this is going to be on top and then this is going to be at the bottom. So we're going to say dy over the x is going to be 2 cos t all over negative 4 sine 2t. Okay, so we have 2 and negative 4. We're going to have negative cos t all over 2 sine 2t. Remember, if you can check, this is a double angle, so we're going to express it, and then we're going to have negative cos t all over 2 into 2 sine of t, also cos of t, where we're going to cancel these two, and then we're going to left with negative 1 over 4 sine t. And then this is still the same as negative 1 over 4 cosec t. Right, if you can check, it's still the same as negative as cosec t all over 4. Okay, so let's find the second derivative of this derivative. So we're going to this open the new one. Okay, we were having n over dy over the x being negative cosec t over 4. Remember, we did have an equation which says the second derivative is going to be d over dt into dy over the x all over the x all over the theta. Remember, we also do have this thing. Okay, let me show you. Remember, we did have the thing on this one. Remember, the x over the t is this one. Also, our dy over the t is this one. But we are going to focus on the x over the t. Sorry, here is supposed to be t. So let's look at here. So remember, here we're supposed to derive our top. Also was going to put the x over the theta. Okay, let's apply that. So let's derive. Remember, we are going to derive this one. Remember, which is this function at the top. So we're going to say our derivative of this is going to be cosec t. It's negative cosec t cot t. Okay. And then let's focus on the other one, which says going to be, remember, we're going to put the x over the t. We said the x over the t is negative 4 sine 2t. And then we're going to say negative 4 sine 2t. Okay. So, and then let's express it. And then if you can check, we're going to have, remember, we have negative here. These negatives are going to cancel, and then you're going to left with cosec t cot t all over, remember, negative 16 sine t sine 2t. Okay, so let's check something here. We are going to say that our cosec t over cos t over sine t all over negative 16 into 2 sine t cos t. And then let's check here. So remember, we have this, and then let's try to separate this and this. This is going to be the same as cosec t over negative 32, which is still the same as times cos t over sine t all over. This is the main divide, and then which is going to say sine t times cos t. Remember? So let's check something here. So we're going to have, let's say we have one here, which when we express it, we're going to have it. Okay, let me write it down there. Cosec t over negative 32 times, remember, this is going to be cos t over sine t, and then times, remember, 1 over sine t cos t. and then remember this will go away, and then you're gonna left with 1. This is going to give you, let me go to the next page, and then let me try to get the new page actually. Okay, so we were having a cosec t all over negative 32, where on the other side we were having 1 over sine square t. Okay, so this is still the same as negative cosec t all over 32 times cosec, this cosec square t, and then remember times this 2 is going to be negative cosec cube t all over 32. So this is your second derivative. So you're supposed to check that, guys. So most of the time, some people they do make mistake on the equation. So you're supposed to remember that we have our first derivative. We say the x, which is still the same as if it's in terms of theta. We're going to say dy over the theta over the x over the theta, which is still the same as dy over the theta times the theta over the x, and this is still the same as the y over the x after this cancel. So I'm going to leave with this one, and then on the second derivative we are going to have the second derivative is going to be d over the theta when it is in terms of theta, d over the theta, which is dy over the x all over dx over the theta. So this is your equation. Remember, it's supposed to use this equation when you go to the second derivative. So watch out, guys, for more videos. Goodbye.